Hello all, welcome to my channel Electronics for All. So we are doing previous year gate series questions and we are on subject signal and system and moving on to the next question set. So the question says that the waveform of a periodic signal xt is shown in the figure. So this is some periodic signal xt which is given and a signal which is gt given as shifted and scaled version of xt like xt minus 1 divided by 2, and they are asking us the average power of gt. So in order to find out the average power of gt, let's just study the signal xt because we have to shift as well as scale this signal, right? So xt signal, if I define xt signal, since it is periodic, it is repeating itself after every 3 interval. So from minus 1 to 1, it is a decreasing slope and decreasing slope of 3. So that I can write as minus 3t from minus 1 to 1, and its value is 0 from 1 to 2. So this is how we can write signal xt. Now we have to write GT signal. So in order to write GT signal, we will perform scaling and shifting operations. So if I scale this first, G dash T, if I'm writing it, so let us scale this. So T by 2. So if I scale this, that means it is T, instead of T, we have to write T by 2. So it will become 3T, 3 by 2 T. And the time interval will be multiplied with 2. So that will become minus 2 to 2. And this is 0, so it won't change. So it will be only this range will change. So 1 into 2 will be 2 till 2 into 2 will be 4. So now our signal will exist from minus 2 to 4, right? But we have to do the complete change, that is including time shifting as well. So now we have scaled this function, now we have to shift it. Now instead of t, it is t minus 1. So gt signal will become 3 minus 3 by 2 t minus 1, which will exist from, so it is shifted. Now we have to add, because it is minus 1, we will add 1 to the shifted version. So it will be minus 1 plus 1 will become minus 1 t, 2 plus 1, that will be 3, and 0, 2 plus 1, 3, 2, 4 plus 1, 5. So this is our GT signal, which will exist from minus 1 to 5. So total time period will become from minus 1 to 5. So time period will be 6. T value will be 6. And GT signal will be minus 3 by 2 T minus 1. Now they are asking to find out the average power. So how we can find out the average power? So average power is given as 1 by T integration from minus T to T and signal xt whole square dt, or you can write t by minus t by 2 to t by 2 or 0 to t, whatever suits you. So here t is 1 by 6. Now our signal only exists from minus 1 to 3, otherwise it's 0. So we will write it from minus 1 to 3 only, and the value of xt here, instead of xt I can write as gt also. So its value is minus 3 by 2 t minus 1 and whole square dt. And if you solve it, you will get average power will be equal to 2. So option number 2 will be your correct answer. right? So moving on to the next question. So next question says that a discrete time signal xn given as sine pi square n, where n being an integer is whether it is periodic with pi square, pi by 2, or it is a non-periodic signal. So how we find out periodic signal, whether it is a periodic signal or not? So here the signal xn is given as sine pi square n. Here we write sine signal as sine omega naught n, right? So omega naught will be equal to pi square. In order to check whether the signal is a periodic or not, we have to find out the fundamental time period, or here in the case of discrete signals, we have to find out the fundamental integer value, that is why that value is n. So its value is 2 pi by omega naught into m, where m should be such value which is integer, that should be exist in order to make the n value to be integer value. So m should also be, it should be smallest integer that converts 2 pi by omega naught into an integer value. So we have to find that value of m. So n is equals to 2 pi by 2 pi by omega naught value is pi square into m. So it will be 2 by pi into m. So there is no integer possible value possible here in this case, because pi is not integer, right? We cannot cancel pi with any integer values. So it is a signal which is not periodic at all. It is not periodic signal. So we can write it is a non-periodic signal. Easy. Moving on to the next question. So next question says that the impulse response of a continuous time system is given as ht is equals to delta t minus 1 plus delta t minus 3. The value of the step response at t is equals to 2 will be. So here impulse response is given t minus 3. Now, in order to get the step response, what is step response? Step response is nothing but integration of impulse response ht. So if we integrate the above signal, we will get the step response. So integrate the above signal. So I will integrate them individually. So it will be minus infinite to infinite del t minus 1. So we will get u of t minus 1, and similarly del of t minus 3, we will get t minus 3. Now we can easily plot the signal. So this is at 0 time, this is time t, 2, 3, 4, and so on. We don't need much of time. So now ut signal is starting from ut of minus 1, that is shifted signal. So it will be present here. Ut of minus 1, right? Here another signal is adding to this, which is equals to ut minus 3. So at t is equals to 3, another ut signal is added. So it will be, so it was 1 1 before, it will become plus 1 plus 1 plus 1 to all the ut signals. So it will become 2 here, like this. So this is the complete signal step response if I write yt. So this is your step response yt. Now they are asking us the value of step response at t is equals to 2. So you can easily see that at t is equals to 2, the value of step response is nothing but 1. So yt is equals to 1. So 1 is the correct answer. Okay. Moving on to the next question. In next question, it is easy because they are just asking us to find out the fundamental frequency, right? And the signal is given like this with different values of different signals. So we have to just find individual frequencies and we have to find the HCF of all the frequencies in order to find out the fundamental frequency. So this is the process. If multiple signals are given, if multiple signals are given in addition only, if they are in multiplication or division, so you have to perform trigonometric identities in order to make all the signals come into addition or subtraction form, and then you can perform in same manner. So you have to find out individual frequencies, and then find HCF of all, and that will give you your fundamental frequency. Let's just find out the individual frequencies of all the above signals. So this is signal number 1, this is signal number 2, this is signal number 3. So I will write omega 1, fundamental frequency of signal 1. So 30 sine 100t, that means 30 sine omega naught t. Omega 1 will be equal to 100 easily. Similarly, omega 2 will be equal to 300 and omega 3. So this is represented as 6 sine 500t plus pi by 4. That means 6 sine omega naught t plus phi. Phi is your phase. So that does not have to do anything with your frequency. So frequency is here only, which is equals to 500. You have to find out the highest common factor between 100, 300 and 500, which will easily come out to be 100. So the fundamental frequency is equals to 100 radian per second. Very easy. And they have asked you in radian per second only. So this is directly into radian per second. If they ask you fundamental frequency in hertz, so you have to divide it by 2 pi. Okay. Moving on to the next question. So the next question says that the input xt and output yt of a system are related as yt is equals to minus infinite to t, the x tau cos 3 tau d tau. The system is whether the system is time variant or invariant or stable or unstable system. So we have seen the condition in which we can find out the time variance or invariance or stability or instability of any system. So let's just first check for time variance or time invariance of a system. Yt, x tau, cos 3 tau, d tau. So I will give you a very easy way in order to check whether the system is time variant or invariant. First, shift the output and write whatever the equation you have. Then shift the input and write whatever the equation you have. And then check whether they are same or not. So first we have to shift the output. T minus T naught will be equal to T minus T naught x tau. Now shift in output will not change any input. Okay, so it will be same cos of 3 tau d tau, because we have just shifted the output. Only limits will be shifted from t to t minus t naught and the input will remain as it is. So x tau will remain x tau only. In next, what we have to do is we have to shift x tau. So x tau will become xt minus x tau minus t naught, right? So some other function I am writing y dash t will become minus infinite to infinite, since minus infinite to t, since we have shifted the input, so it will be x t tau minus t naught cos 3 tau d tau. Now in above both the signals 1 and 2, the limits are different. So we have to make sure that the limits are same. Then we have to check both the signals are same or not, right? So we have to make the limits same. Make the limits limits same. So we have to convert x t minus tau. We will shift. We can say that instead of tau, I am writing Instead of tau, I am writing tau plus t naught. So it will be minus infinite to t minus t naught x of tau cos of 3 tau plus t naught d tau. That's how the limits will be changed. Now, if you check y t minus t naught and y dash t, so they are not same. So y t minus t naught is not equal to y dash t, right? So it means that it is a time variant system. Time variant system, or you can write that it is not time invariant, right? So this system is a time variant system. Now we have to check for the stability of the system, right? Stability. Yt is given as minus infinite to t x of tau cos of 3 tau d tau. So in order to check the stability, what its stability says that if input is bounded, output should also be bounded. Output should also be bounded. That is the only condition in order to check the stability, which is known as BIBO. So there will be many input functions that can satisfy BIBO. We have to just find one function that does not satisfy a BIBO in order to check whether the system is stable or not. Right. So let's just see that if I make the signal x tau as cos 3 tau only, which is a bounded signal. Right, cos signal is a bounded signal, so it is a bounded input I have provided. So yt will become from minus infinite to t cos of 3 tau square, right? Cos square 3 tau d tau. Now, if time t approaches to infinite, this signal also approaches to infinite only. So that's why it is a not bounded, it is a not bounded output at this particular bounded input. So we have given one bounded input and output is not bounded at that particular input. So I can say that it is a not stable system. Not stable system. In order to check the stability, you have to just find out that particular function in which does not satisfy the BIBO condition. So yeah, that you have to find and that will come with practice. So here we can easily say that cos square function does not, it is not a bounded system. So cos square theta is not a bounded system, but cos theta is a bounded system. So we can easily find out that it is a unstable system. So which option will satisfy? So it is a not time invariant and a not stable system. Option 4 will satisfy this result, right? Moving on to the next question. So next question says that the input and the output of a continuous time system are respectively denoted as xt and yt. Okay. Which of the following depicts the corresponds to the causal system? So we have to find out the system, whether the system is a causal or not, not sorry, causal. It is, we have to find out if the system is a causal or not. So which system is causal or not? So now, if we see option number A, this is on present value, right? Okay. But this system, so this is depending on future values. So it is a non-causal system. Now this system, t minus 1, x t plus 1, again, future values, it is a non-causal system. Now this one, t plus 4 xt minus 1, this this is not a part of input. We have to just check for the input. In causal system we have to check whether the input values depends on future values or not. Okay, so it is past values, this does not matter, this is the coefficient. So it is a causal system. Here again, this is future values. It was very easy question. So it is a non-causal system. So option C will be correct option. So option C only says that it depends on the past values. So it is a causal system. All the three are non-causal systems.